be calculated. So here you have oxygen is -2. So automatically here you have -2 multiplying by 2 moles, then hydrogen is, you have 4 of hydrogen which is unknown, equals to 0. 4H plus 2 times -2, that's -4, equals to 0. So 4H equals to +4. So divide both sides by 4. So here hydrogen is +1. So it changes from 0 to +1. Therefore, the answer to question number 2 is, it changes from 0 to +1, which is D. So it changes from 0 to +1. D is the answer to question number 2. Question number 3. Oxidation state of sulfur in tetrasulfuric 6 acid, H2SO4. Since this is a compound, the algebraic sum is equal to 0. Hydrogen is +1. You have 2 atoms of hydrogen here, so 2 into +1, plus sulfur, which is what we have to calculate, plus oxygen is -2, 4 atoms, making it this, equals to 0. Equals to 0. So this one is +2, sulfur -8 equals to 0. +2 minus 8, that's -6. S minus 6 equals to 0. So S will be +6. So the oxidation number of sulfur in H2SO4, which is tetrasulfuric 6 acid, is +6, which is B. Then question number 4, what is differentiate between oxidation and reduction? Oxidation is the loss of electron, while reduction is the gain of electron. Ionic theory. Ionic theory has to do with the interaction between ions. Electrovalent compounds. What are electrovalent compounds? Electrovalent compounds are compounds involving the transfer of electrons from an atom, usually metallic, to another atom which is non-metallic. What are the examples of compounds that exhibit electrovalent bonds? You have sodium chloride and magnesium oxide. You have so many others, but in this regard, it must be between a metal, because it's the metal that will transfer the electron, while the non-metal will accept the electron. Electrolytes. What are electrolytes? Electrolytes are compounds in molten form or in solution that conduct electricity. Example is tetrasulfuric 6 acid and copper sulfate solution. Tetrasulfuric 6 acid is an electrolyte because it dissociates to H2H plus SO4 2-, and at this state is able to conduct electricity. Also, copper 2 sulfate exhibits the same phenomenon, where you have copper 2 plus ion to SO4 2-. At this state is in solution and can conduct electricity because of the free mobile ions. Non-electrolyte. What are non-electrolyte? Non-electrolyte are solid materials or compounds that do not conduct electricity. Strong electrolytes. Strong electrolytes are compounds that conduct electricity completely. They conduct electricity completely. Example is tetrasulfuric 6 acid. That is a very strong electrolyte because you can see it here that it's able to split into ion completely in order to conduct electricity. Weak electrolytes. Weak electrolytes are compounds that do not or conduct electricity in a little extent. They do not conduct or conduct little electricity in the process. What are those compounds, mostly organic compounds. Example, ethanol, ethanoic acid. Electrochemical series. What is electrochemical series? An electrochemical series that is a series that shows the position of ions and their relative reactivities. It shows the position of ions and their relative reactivities. Factors affecting the preferential discharge of ions. Ions are preferentially discharged. There are some factors that are responsible for this concept. The first one is the position of ion in the series. The position of ion determines the conductivity of that ion, and it determines the reactivity of that ion. Concentration of ions. Concentration of ions also determines the rate at which a particular ion will be discharged or not. Then the nature of electrode use. That is the third one. The nature of electrode use also contributes to the rate at which a particular ion will be discharged or not. Electrolysis. What is electrolysis? Electrolysis is a chemical decomposition of a compound brought about by passing direct current through the solution of the compound or the molten compounds. Electrodes. What are electrodes? Electrodes are conductors in the form of wires, rod or plates through which an electric current enters or leaves the electrolytes. We have two types of electrodes. We have the cathode and the anode. In the cathode, they are negatively charged electrode, while the anode are positively charged electrode. Electrolytic cell. What is an electrolytic cell? It is a device that converts electrical energy into chemical energy. Electrochemical cell. What is electrochemical cell? An electrochemical cell is a device that converts chemical energy into electrical energy. The difference between the two is that electrolytic cell converts electrical energy into chemical energy, while electrochemical cell converts chemical energy into electrical energy. Electrolysis of acidified water. When they say acidified water, we are talking about water that comprises of H2SO4, which is what brings about that acidity. In that situation, electrolysis of acidified water. Acidified water has H2SO4, which dissociates into ions in this form. 2 minus. Then the water itself, which dissociates into H plus OH minus. And we all know that ion can only move to the anode or the cathode depending on the charge. Cathode is negatively charged, while anode is positively charged. Since like poles repel and unlike poles attract, that means the ions that will migrate to the cathode will be positively charged because cathode is negatively charged. So these ions that are positively charged, which are also called cations, these ions that are negatively charged, they call them anions. So the cations migrate to the cathode. The cations migrate to the cathode, giving you, these are the cations that will migrate to the cathode, while the anions migrate to the anode because of their charge. Now, you have 2 ions of the same content, that is hydrogen ions, on the cathode, and you have sulfate ion and hydroxide ion on the anode. So remember that one of the factors that affect the relative discharge of ion in the electrochemical series is the position of ion. And in the position of ions, it has been established that since these are of the same ion, one will be discharged. So let's say H plus is discharged. Yeah. On the anode, because of the fact that you have the anions, and what happens in the case of the anion is FSN chlorobrio. Here you have the respective anions, and if you check this very well, you will see that hydroxy is higher up, so it will be discharged in preference to sulfate, which is lower down. So in that situation, OH minus is discharged. And when this is discharged, it will be of this form. 2 electrons to give hydrogen. So hydrogen gas is liberated